Hello, students. I hope you are doing well. So, let's start with today's BPT chemistry solutions. I hope you have done these good. They were quite easy. So, let's move to our first question. It says, which of the following is dihydric alcohol? Okay. What is dihydric alcohol? This moiety would be dihydric alcohol. Okay. So, let's see. The options given are glycerol. What is the structure of glycerol? Glycerol will be this. Okay, so this would be glycerol. So this is not the answer. Next is ethylene glycol. Yes, this is the answer. Why? Because it has this moiety. This is CH2OH, CH2OH. Okay, catechol and resorcinol. These will be benzenoid structures. Okay, with two OH group. So our next question is an example of a compound with functional group O is, let's see what all the options given to us are. Acetic acid. See, acetic acid, we all know this is COOH. Methyl alcohol. This would be OH. Diethyl ether. This will be O. And acetone, this is CO. Alright. So, our correct answer is diethyl ether. The next question is assertion and reasoning. Assertion says the general formula for a dihydric alcohol is CnH2n OH whole twice. And the reason says ethylene glycol is a dihydric alcohol. C है the general formula of dihydric alcohol is this, which is correct. What you see is ethylene glycol is a dihydric alcohol. This reason is not providing the correct explanation to the assertion given. We know that ethylene glycol is a dihydric alcohol now. In the first question, we saw that. So this does not provide the correct reason. Why is it so? So the answer would be B. Okay, the general formula comes from the struct. The general formula comes from the structural characteristics of dihydric alcohols, not from the specific example of ethylene glycol. Okay. So the next question is match the following options. See, this we all know. This is phenol. Okay. These two we will see. Right. Now see where is phenol given. This is A and phenol is given in Q. So let's match the options. Whether A is given. See, we have now two options. And see, this this structure is catechol. Okay. You have to keep this thing in mind. And this is resorcinol. And this is quinol. Okay. This is not hydroquinone. That would be this. Okay. So D matches with hair. P. So it is there in this option. So correct option would be alright. So our next question is which one of them is an incorrect match? We have to tell which is the incorrect match. Diethyl ether. Let's see the structure. This is a simple ether, yes. Mixed ether C2H5 and C6H5. You can see that in the functional group is in the center and the groups attached are different. They are not same. See, this is simple and symmetrical, but this is a mixed ether. This has two different Now let's see. This is an unsymmetrical ether. This is also correct because this is C2H5 and this is CH3. Now what is given next? C2H5, O C2H5. See, this is a symmetrical ether, not unsymmetrical ether. Okay, so the correct answer would be D. They have same groups. Okay, see, these have same two groups. Now what is given in the question? How many sigma bonds are present in CH3, CH2OH? Let's see the structure. Oh, wait. See, this would be the structure where C, H, C, H, C, H, H, O, H is there. Okay. So this is our structure. What are the sigma bonds? 1, 2, 3, 4, 5, 6, 7, 8. So the correct answer would be 8. Now let's see the next question. It is given to us in ethers two bond pairs and two lone pairs of electrons on oxygen are arranged in. We have to tell the hybridization. See, the hybridization here would be sp3. You know the structure of H2O, right? Like in H2O, we can compare it like this. So this is the structure, alright? So this is tetrahedral. Oxygen is in tetrahedral when it has two lone pairs and two sigma bonds. Okay? So see, in ethers, the four electron pairs, two bond pairs and two lone pairs are arranged approximately in tetrahedral arrangement. So this would be the arrangement. Why? Because let's see the planar example. It should be this, or linear could be this, like in CO2. Okay. What is trigonal bipyramidal? It is this arrangement. So the correct answer would be tetrahedral. Now let's see the next question. Which of the following compounds containing hydroxyl group is used for polishing wooden furniture? C. What we use is ordinary spirit. Okay. It is used for polishing wooden furniture and it contains hydroxyl group. Okay. That is ethanol. That is ethanol. Okay. That we can say is ethyl alcohol also. So the ordinary ethyl, not diethyl alcohol, it's ethyl alcohol. So ordinary ethyl alcohol is referred to as ordinary spirit. So the correct answer would be C. Let's see the next question. Which of the following functional groups is present in paper, cotton, and sugar? See, we all know in biomolecules we have studied the structure of sugar, which has OH groups. All right, like this somewhere. Like every structure is different. So now we know which group is there. Okay. So it is not NH2. Yes, it is OH. Okay, and the option would be B. So the sugar we eat, the cotton used for fabrics, and the paper we use for writing are made up of compounds containing OH group. Something as cellulose, something else. So these are all the polymers of sugar. Okay, so OH will be there. Let's see the next question. The substitution of a hydrogen atom in a hydrocarbon, often alkoxy or aryl oxy group, yields another class of compounds. See, if I have a hydrocarbon, and for example, I'm substituting with alkoxy group. So what will it become? This will become ROR dash, right? And what is this? This is an ether. So what would be our answer? That would be ether. And substitution would occur. So here you see the example. For example, we have CH3OCH3. By replacing, for example, we had a CH4 and they replaced by CH3O negative. What it became? It became CH3OCH3, right? So correct answer is ether. Let's see the next question. Which of the following alcohol contains COH sp3 bond? Let's see. Allylic alcohol. What is the structure of allylic alcohol? It is this. This is this carbon is sp3 carbon. So our correct answer is this. In vinylic we have this. Okay. And in phenols, this is sp2. And in phenols we have this structure. Again, this carbon is sp2. So the correct answer is 61 goes for A. Let's see the next question. Identify the primary alcohol. Primary alcohol, or we can say is 1 degree alcohol. See, this is not a 1 degree alcohol. This would be 2 degree. This would be 1 degree, and this would again be 2 degree. This would be 3 degree. So correct answer is B. Because primary alcohol is CH2OH. Let's see the next question. Which of the following statements is our true? We have to tell the true statement. So, in if both the alkyl groups are the same in ethers, the prefix di is added before the name of alkyl group. Yes, this is true. Why? Because, for example, we have this group. We saw earlier that this is called as diethyl ether. Okay, so this is correct. Let's see the next option. Ethers are regarded as hydrocarbon derivative. Which hydrogen atom is replaced by OAR group? The larger OR group is chosen as the parent carbon chain. See, we just saw in this question that this is the case in ethers. So our correct statement is B as well. So B and C are the correct options. And the larger chain, the larger R group is chosen as the parent hydrocarbon. So let's see the next question. The question given is select the incorrect statement. Now here we have to select the incorrect statement from the following options. Let's see what all are the statements given to us. The common name of an alcohol is derived from the common name of the alkyl group by adding the word alcohol to it. See, for example, I have C2H5OH. It is also called ethyl alcohol, okay? And how we came up with the name? This is C2H5. The alkyl name is ethyl, and we just added alcohol after it. So it became ethyl alcohol. So the statement A is correct. For B, we have the IUPAC name of an alcohol is derived from the name of the alkane guess there's some ambiguity here in the question and answer. Let's see. The IUPAC name of an alcohol is derived from the name of the alkane from which the alcohol is derived by substituting E of the alkane with OL. Let's take ethanol only, C2H5. It was ethane, and we dropped E, right? E was dropped, and all is added to, and it became ethanol. So this is also correct. In the next question, the longest carbon chain is numbered starting at the end to the nearest hydroxyl group. The positions of OH group and other substituents are indicated by using the number of carbon atoms to which these are attached. See, it says that, for example, we have this. How we'll number it? We'll be numbering it from here 1, 2, 3, 4. Okay, so from where did the numbering started? It started nearest to the alcohol group carbon. So this is also correct. Let's see the next statement. In case of polyhydric alcohols, the E of alkane is not retained and the ending of ditriol is added. See, for example, I have this. Okay, this is common name is glycerol, but how will I name it? Let us see, one, two, three. So it would be propane triol. So what happens here? See, E is retained. They are saying it's not retained. So this is the incorrect statement. Okay. So the correct answer would be D. Okay. So the numbering is same here. Okay. Now let's see the next question. Acid catalyzed hydration of alkenes, except ethene leads to the formation of C. It is saying that we have an alkene and its acid catalyzed hydration will lead. See, we'll get an alcohol that is for sure. But now will it be primary, tertiary or secondary? Let's see. Now it depends on the nature of the alkene. Okay, if it is substituted or not substituted. See, let's see. We have this alkene, and upon acid catalyzation, what happens? We'll have like this, and our carbocation will be here, and OH will attack this. Okay, so what happens is the carbocation is formed where the stability of carbocation is more. That is in this order. Okay, so what we get here is secondary alcohol. Now let's see the example of substituted alkene in which the attack will be there and we have the carbocation here. So OH group will attack here and it will form 3 degree, that is tertiary. Okay. So what is the answer? It is either primary, secondary or tertiary. Primary is not formed because what we see is the non-terminal carbon carrying double bond. For example, in alkene Y has a substituent attached. Tertiary alcohol will be formed because carbocation will rearrange itself. So the correct answer would be secondary or tertiary. Okay. Now let's see the next question. Ethyl alcohol can be prepared from Grignard reagent by the reaction of. See, how do we prepare Grignard reagent? We have any moiety. Ethyl alcohol we have to do. So, for example, we have this. So, Grignard reagent, what is the ethyl alcohol? It is C2H5OH. So, the Grignard reagent will be MgBr. Okay. So, just a second, yeah. So what happens is it will go here, and what we will get? We will get OMGBR, R, and here a group, and this. So we want it to be CS3, CH2, CH3, CH2OH. We already have a carbon here, you see? We already have a carbon. See, one carbon is already there. And what we need is one more carbon here. So what we will do? R will be CH3. So it would be here what will be? It will be H. That is CHO. The correct answer is A. Let's see a more detailed explanation. The structure is this, and the Grignard reagent. See, this is the negative charge, and here it would be plus. So what happens? It would come here, and this would go here. And what we will have? We will have H2CCH3O minus. Okay, so MgBr will attach, and we will have this structure. And then on treatment with H3O positive, protonation would be there, and we will have this. That is an required structure. The correct answer is A. Now let's see the next question. Mm, Isopropyl alcohol is obtained by reacting which of the following alkenes with concentrated H2SO4 followed by boiling with H2O. What is isopropyl alcohol? This is CS3, CH3, and OH is here. That is secondary alcohol, and propyl group is there. So, if you need to know the alkene, what will happen is let's just remove H2O because upon addition only it became alcohol. So, we'll just follow the reverse psychology here. And what will it be? Like, it would be, example, I had H here, one H. Let me make it more clear. Yeah. So, these will go and the double bond will come here. So, what we will get? CH3, CH, CH2, right? So, what is our answer? This is propylene. The answer would be B. Now, let's see the next question. Which of the following reacts with NaOH to give alcohol? Let's see. See, the aldehydes that do not have alpha hydrogen atom will react with NaOH. Okay, see, this is a very famous reaction. That is the Cannizzaro reaction. Okay, in which one product is alcohol and the other product is carboxylic acid salt that we can then form carboxylic acid. Okay, so it should not have alpha hydrogen. The aldehyde should not have alpha hydrogen. And these are reduced to alcohol and the other molecules are oxidized to acid. So this is the reaction taking place. One is CS3COH and then other is HCOONA. So the correct answer is B. See, this has alpha hydrogen. Why? Because it has CS3 group with it. Now let's see the next question. Commercially, carboxylic acids are reduced to alcohols by converting them to C. We have carboxylic acid. What we can do? They can be reduced to alcohol. If we need alcohol, we need to convert it to ester. Okay. Then only we will get C in this reaction. then only we will get alcohol. Or you can see esterification reaction. This is the reverse of that, right? So the correct answer would be A. This would be catalytic. It is written at catalytic hydrogenation. Now let's see the next question. Aldehydes and ketones are prepared by the oxidation of, this is really easy. See, if I have CH2OH, it can be converted to CHO. That is a primary alcohol. And if I have for ketone, what I need? Secondary alcohol, because it is this case. Then upon oxidation, we'll have this. Okay, so the answer would be primary and secondary alcohols. You have to take, see, you have to keep in mind the correct thing. It should not be secondary and primary. The order here is important. Now let's see the next question. Alcohol vapors are passed over which of the following catalysts to give aldehydes and ketones? C. What is the key concept here? That is the dehydrogenation. Okay. Dehydrogenation of alcohol. You might have seen in reactions we are using Cu or Ag for the dehydrogenation of alcohols. Okay. So C. That is, these are heavy metals. So the correct answer would be B. Alcohol vapors passed over heavy metal catalysts to give aldehydes and ketones. Primary and secondary alcohols give aldehydes and ketones respectively. This we saw in the last question. So let's see our next question. The acid catalyzed hydration of alkene involves the following three steps. The nucleophilic attack of water on carbocation, the protonation of alkene to form carbocation by electrophilic attack of H3O positive, and deprotonation to form alcohol. And we have to identify the correct sequence. Okay? So what we will do? See, in the third step, you see deprotonation to form alcohol. Alcohol is formed. And what is formed in the hydration of alkene? Alcohol. So this would be our last step. Okay. So we got that three would be our last step. And let's see the other steps. The mechanism follows by step one, that is protonation of alkene to form carbocation by electrophilic attack of H3O positive. Okay. So what happens is this alkene will react here and we will have a carbocation. Carbocation will be formed there because it would be stable. Okay, stability of carbocation. Stability of carbocation is important. Then the next step would be, now if we have an electron deficient species, what will happen? Always an electron rich species will attack on the electron deficient species. So this here will attack here. See, this is lone pair. So lone pair can also attack not only electron rich species. Lone pairs are also there to attack. So what we will have this now, always remember OH2 positive. This is a very good leaving group. Okay. OH is not a good leaving group. OH2 positive is. We will get the attack will be here and this will be removed and OH will come here. Okay. Or in other ways, other simple words that would be difficult. So what you can do is, we have now OH2 positive. So what can happen? We need OH, this H electron, the bonds of the electron of the OH bond will come on O. This positive will be neutralized and it would be simple O, and H here we will have this. Okay. So the next question is, so the correct answer here would be B, 2, 1 and 3. Now let's see the next question. Consider the following statements. Alcohols undergo dehydration in the presence of protic acids such as H2SO4, H3PO4. Dehydration of alcohol is the best method for preparation of unsymmetrical ethers. And phenols can easily be converted into ethers by Williamson synthesis. Ethers are used as industrial solvents for oils, resins, gums, etc. See, let's see what is the correct answer. C. The thing is, the wrong statement here is this. Okay, because it's not the best method. This is not the best method to prepare the unsymmetrical ethers. Dehydration of alcohol is not suitable method. Since complex mixture is obtained, we obtain a mixture. For example, we have A plus B, so it's very difficult to separate this. So the correct answer here would be 1, 3, and 5. These are the correct options. See, for the first option, alcohols can undergo dehydration. This is given the reaction to support the answer. Now let's see the next question. Assertion says increasing order of acidic strength of alcohol is 1 degree, 2 degree, 3 degree. And it says that the electron group, the reason says electron releasing group increases the electron density on oxygen, which tends to decrease the polarity of OH bonds. So here both are correct. What happens is, for example, if we have 1 degree, 2 degree, and 3 degree alcohol, so the R group here is donating its electron and destabilizing it. The electron density on OH will increase. So the COH, this bond polarity, it will suffer. Okay. More the number of OH groups, more will be the instability. So the answer is correct. Reason is also saying the same thing because stability has direct relation with acidic strength. Okay. For this, we remove the OH of the H of OH and we form O negative. Now you can see it will be more easy for you to understand. More the R group, more will be the destability. So the correct answer is A. Now let's see the next question. It says cresols are less acidic than phenols. Let's see the structure of cresol, which is, and phenol is this. Now you can easily notice this that in COH and CH3, when both are there in cresol, this is electron releasing group. So it will destabilize this. And electron density on O will increase, leading to instability and lesser acidity. So which would be the correct answer? Electron releasing group will not favor the formation of phenoxide ion, resulting in the decrease in acidic strength. Here it is very much stabilized. We have this, phenoxide ion is this. So it will have resonance. It will also have, but destability will be here when, see, when O negative, this will go here, and when here we will have negative charge, and here we have CH3. So it will destabilize. So the correct answer would be C. Now let's see the next question. In the following reactions, this is the reaction given to us. The major products are C. Here we have this group OH and H plus is given. So dehydration will be there. So what happens? Alkene will be formed here. According to Sedgwick rule, because more substituted alkene will be the stable. So this would be the major product. What? CH3, CH, CH3, CH, CH3. Okay. So this would be the major product. And now, minor product will be CH double bond CH2. Then we have CH2, Me, and Me here. Okay. So then this on reaction with HBr, what will it give? If we have this, see, we have this. Now on reaction with HBr, what happens? We have H positive and Br negative, right? So we'll have Here carbocation will form and the nucleophile will attack here because this is the stable carbocation. So we will have Br here, which is the major product. We have to tell A and C, which corresponds to option number C. Okay, so let's see the next question here. Which of the following options are true? This is the option given to us, A, and this is B. This reaction. And the other option, there is cleavage of CC bond in oxidation reaction by weak oxidizing agents, KMNO4 under the weak reaction condition and all of the C. This is false. Why? Because the double bond will not be affected when PCC is given. It is only the oxidation of primary alcohols to aldehydes. Okay, so this would be the product. Now this is correct because according to this reaction, we'll have COO R C double bond O R dash. Okay. Now, according to next option, there's cleavage of CC bond in oxidation reaction. You see here, oxidation is happening, and we have COOH. See the bonds broken are CH, CH, and CH. No CC bond is broken. So the correct answer would be this. Now let's see the next question. The salicylic acid and phenol can be distinguished by the use of. Let's see the structure of both. Okay. So our salicylic acid is this, and phenol is this. And let's see the options. See bromine water. In case of bromine water, we can detect unsaturation. Okay, but there's unsaturation in both, so there won't be any primary difference. In case of neutral FeCl3, what happens is salicylic acid will react with neutral FeCl3 and it will form a purple colored complex, which indicates the presence of phenolic group. Because it already has a phenolic group, and phenol will also do the same. So this is also not useful. Okay. And in case of NaOH solution, what happens is they will both dissolve to give sodium salt. This is also not a determinatory factor. Let's see in option D. Obviously now all are wrong, so this is correct. Why? Because of the reaction, this will form. Okay, here we have COOH and the reaction would be there. Okay, so CO2 will be released and effervescence would be there. But in case of phenol, there is no COO group. So there would be no reaction. Okay, so the correct answer is D. Now let's see the next question. Mechanism of acid catalyzed hydration reaction involves. So the options are protonation of alkene to form carbocation by electrophilic attack of H3 positive, nucleophilic attack of water and carbocation, and deprotonation to form alcohol. And we have to tell the steps involved. Okay, so let's see which all are the steps. Let's see the mechanism. In step 1, we have protonation of alkene to form carbocation. So alkene will attack here and we'll have this. Okay. So what we get is this carbocation and according to stability, the plus charge would be here. Then there would be, now if we have a carbocation, we'll have the nucleophilic attack. So water will attack here, we have this, and then deprotonation would be there. Okay. So we will get this group, this moiety. So all the steps here are involved. So the answer would be 1, 2, and 3. So let's see the next question now. Among the following sets of reactants, which one produces anisole? What is anisole? This is anisole. Okay. How can it be produced? So we have O group here. So obviously what we need is alcohol. We should have OH. It is there in these options. Now let's see the further options. So ether. This is an ether. Okay. So we know alcohol with any alkyl halide gives ether. Okay. Alcohol with alkyl halide. And if it is OCH3, then we have CH3X halide. So this would be B. Let's see the reaction. O. So OH, and this is O negative. Then we have CH3. Okay, wait, let me make it more clear. We have OH and we have NaOH. Okay, so we have this group. So we get is phenoxide. Okay, now we have CH3 plus and I negative. So negative will react with this. So we have OCH3. So the correct answer would be B. Which of the following will not be soluble in sodium hydrogen carbonate? Let's see. Here, these will be soluble but not this. Why? Because what is orthonitrophenol? This is OH and this is NOO. Like everyone is described here. It's resonating. So this is H. So we have this bonding here. So this is very strong intramolecular hydrogen bonding. So this will not break and dissolve. The correct answer would be C. The orthonitrophenol will not be soluble due to intramolecular hydrogen bonding. So it cannot behave as an acid and cannot react with sodium bicarbonate. Now let's see the next question. The compound A on treatment with Na gives B and with PCl5 it gives C. B and C together to give diethyl ether. A and B and C are. Let's see. If with Na it is giving B, and so we have B. And with PCl5 it is giving C. So here we have this is like a very common reaction for the preparation of alkyl halides. So we have RCl here, okay? We do not know what is our substrate first. So let's consider it R. And here we have RB, RNA. And B and C will react to give diethyl ether. Now, when we have diethyl ether, when we have alkyl halide and we have a moiety with O negative, okay? So what we will get here? We have this. You see, it will form B, and then we have a C. Let's see the reaction now. C2H5 with Na, it will give C2H5 O negative Na positive, and with PCl5, it will give ethyl halide. These upon reaction will give diethyl. Okay, so in this order is wrong, and in this we have RH, that is alkane. We cannot get ether here. Now let's see the next question. Phenol in treatment with CO2 in the presence of NaOH followed by acidification produces X as the major product. X on treatment with this anhydride in the presence of catalytic amount of H2SO4 produces. This is Colby-Smith reaction. Okay, so let's see. So we have phenol. This on treatment with this and acidification will give salicylic acid. Okay, and then upon acetylation, here we will have O, which will see we have this row. All right. So what will happen here? That O negative will react. Okay. So this will react and the other moiety will go. So what we will get? We will get the option A as our answer. Now let's see the next question. This is given and this is given. We have to tell why. See, in this we have Cl, CH2, CH2, O negative because obviously we take the anion for acidity. Then we have CH3, CH2, O negative. Now it's very easy to determine. See here, R group is destabilizing by donating electrons. Stabilizing, but somewhat stabilization is there due to Cl. So minus I of chlorine will disperse negative charge to produce more stable anion. So C would be the correct answer. Here cation is written. Now let's see the next question. The reaction can be classified as. This is quite easy now. We have alkyl halide. We have this moiety. And this is Williamson ether synthesis. Okay. Now let's see the next question. The major product formed in the following reaction is. C. Now here the lone pair of oxygen will attack on HI. Okay. Now we have two oxygen here. You see. So what happens? Let's see. For example, if we take the attack from this oxygen, we'll have H here and the carbocation will be here. Okay. But in case if we take it from this here oxygen, we will have the oxygen here and plus charge here. And the plus charge then would be formed here, which is very stable. Benzene ring cannot have the plus charge. It's sp2 carbons already, it has lesser number of lesser stability. So plus charge will be very unstable on the sp2 carbon. It is stable on sp3 carbon because it has more electron density to stabilize it. So it will be from oxygen, and then we have this carbocation and we have the nucleophile I negative, which will attack here. So the correct answer we will get here to be D. Okay, this will be OH. I will react here. It will here H will come from HI. Now let's see the next question. Which among the following optically active amine will produce optically inactive alcohol on treatment with KNO2 and HCl? See, we need optically inactive alcohol. So here this NH2 will be converted to N2 positive. Okay. Then this will leave. This is a leaving group. So we have plus on this carbon. Okay. And then what will happen? See here, the stability, according to stability, carbocation will shift. Rearrangement will take place. So here it would be rearranged here because it has more number of alpha hydrogen. Okay. Here it will remain here only. And in this case, it will fit here. Okay, we need now optically inactive. Here you see in optically inactive, the groups are different across the carbon. Here all the groups are different. Here it would be Cl and so it is optically active. Here this is also optically active because here we have CH3. Here we will have Cl, H and here this group. And here we have two CH3 groups that is optically inactive. So this would be the correct answer. This is the mechanism of the reaction you can see. Now in case of next question, this conversion can be achieved by what is this? CH2, right? We have six carbons. Let's just remove it. So 1, 2, 3, 4, 5, 6. We need to tell from what all options we can achieve this. So let's try all. C O3 and Zn n plus H2O. This will oxidize this and give this moiety. Then LiH4 will reduce and give this. Then the other reagent set of reagents will give this, and LiALOH will then reduce it to again give the same product. And then cold dilute KMnO4. What will it do? It will like it will add OH here. Okay, dihydroxylation would be there. And then we have HiO4, so this will oxidize it to CHO. And then here we have LAH, that is LiALH4. This will then oxidize it to CH2OH, CH2OH. Okay? The correct answer would be all of these. Let's see the next question, which is tertiary butyl methyl ether is not prepared by the reaction of tertiary butyl bromide with sodium methoxide. The reason given is sodium methoxide is a strong nucleophile. See, in tertiary alkyl halide, if it is used, an alkene will be the only product. Okay, and no ether is formed because you see it is CH3 from all the sides, so alkene will be formed. For the reaction CH3ONA with sodium methoxide, because it is given, that is why we are reacting with CH3ONA with the given tertiary butyl bromide, and it will give two methyl propanes in this reaction. Here this will go, double bond will be here in any of the case, it would be same. We have 2-methyl propene, NaBr and CH3OH. And the statement that sodium methoxide is a strong nucleophile, it is also true because these are very strong nucleophile as well as strong bases. So they will react with alkyl halide leading to elimination reactions. See, both correct, but reason is not explaining why the assertion is happening. Correct answer would be B. That it is not the correct explanation. Now let's see the next question. pKa values of some phenols and ethanol are given. Let's see the relation between pKa values and the acidity. Okay. So more the pKa, Ka would be lesser and acidity would also be lesser. Okay. So pKa is inversely proportional to acidic strength. Now let's see the statements. The greater the pKa, we have to tell the incorrect statement, okay? The greater the pKa value, stronger is the acid. This is false. Now we know why. Phenol is million times more acidic than ethanol. If phenol is acidic, so its pKa should be lesser. Let's see. Phenol's pKa is 10 and ethanol is 15. So there's quite huge difference. Phenol is less acidic than orthonitrophenol. See, phenol pKa is 10 and orthonitrophenol is 7.2. So this has lesser pKa, so it will be more acidic. So this statement is also true. Ortho and paranitrophenol are nearly equal acidic strength, so their pKa should be near. That is 7.2 and 7.1. So this statement is also correct. So correct answer is A. Let's see the next question. The correct order of reactivity of the following compound with pH MgBr is. So let's see the structure. For CS3 we have, and for this we have. Okay. So C. Here pH MgBr, which is a Grignard reagent, here negative charge. So it will attack on the electrophilic carbon, carbonyl group. It will attack here, it will attack here, and it will attack here. See, here the electrophilicity it's much more compared to both of these. Okay. Why? Because see, we need more electrophilicity because nucleophile is attacking, so the positive charge should be more. Here, only one electron releasing group is there. Here two electron releasing groups are there, and here we have two PH. Lot of steric hindrances there, like this and this. We have CO. Okay. So how will a nucleophile come if there is no space to approach the electrophile? So the correct option would be second, one three, then one. That is D. Okay. Now let's see the next question. An optically active compound X reacts with phenylhydrazine to form phenylhydrazone. The compound X gives yellow precipitate to form of iodoform with iodine and NaOH. See, if this is the case, then we have this group. Okay. So what is given? Optically active compound X. So we have this group and it should be optically active. That is, the other two groups should be different. Let's see the option. Here, no methyl ketone is there. Here, methyl ketone is there, but it is not optically active. Okay. Here, you see, here this would be optically active. See, here it is not optically active. Why? Because two CH3 groups are there. And here two hydrogen. Here, both the carbons are optical. Here it is optically active. The one attached to carbonyl. Okay, here we have two methyl groups. Okay, so only one is the only left option is C, which is the correct optically active. C. This has chiral carbon atom. Now let's see the next question. Select the incorrect statements about the Lucas test. We all know what happens in Lucas test. ZnCl2 and HCl reaction is there. And what it does, it differentiates between primary, tertiary, and secondary alcohols. So the option 1 is correct, and option 2 is also correct. And it is given alcohols are insoluble in Lucas agent. This is really false. Why? Because if it is insoluble, then how we will distinguish between all the alcohols? So it is soluble. Okay, and tertiary alcohol produce immediately turbidity. Yes, this is true. See, alcohol is soluble in Lucas reagent. And because they have to be able to react with alcohol to form corresponding alkyl chloride. So it can only occur if the alcohol is soluble. And tertiary alcohols will immediately react. Secondary within 5 minutes or so. Primary will not react appreciably. Sorry. Now let's see the next question. This is the reaction given to us, and we have to identify the compound mix. This is a Perkin reaction, okay? And in this we have alpha beta unsaturated acid with us that is obtained. This is alpha beta unsaturated acid, okay? And when it is obtained, when we have aromatic aldehydes, okay? See, so it requires a reaction between aromatic aldehyde and acid anhydride. This is acid anhydride. Aromatic aldehyde is already given, so we have acid anhydride, okay? So the acid anhydride among these is this. As the acid carboxylate is sodium acetate, it is CH3COONA. So acid anhydride would also be acetic anhydride. Now let's see the next question. This is a reaction given to us and NaBH4, which is a reducing agent and a strong reducing agent. But LiAlH4 is the father of all reducing reagent. So what will happen? See, NaBH4, it will reduce the carbonyl group, but it won't reduce ester because it is a strong one, but it is not so strong as compared to LiAlH4. LiAlH4 can reduce all, but not NaBH4. So the correct answer would be this. Now let's see the next question. What is the final product of the reaction? This is the reaction given to us. This is our oxide and this is ethanol and this we have PHCH2Cl and phenol is given to us. Let's see. Phenol is given. Firstly, we will have phenoxide ion. Okay. And now see what can happen. We have two nucleophiles here. This and this. And we have PHCH2Cl, which is a stronger nucleophile. This because here the stabilization is there, so its reactivity is a bit lower. Nucleophilicity is reduced. This is more stable. This one, and this will therefore react here, and we will get PH2. Cl will go as a leaving it, and this is the product we get, which corresponds to option C. Now let's see the question number 96. Assertion says the cleavage of CO bond in ethers take place under drastic condition with excess of hydrogen halide. And reason says ethers are the most reactive among all the functional groups. See, reason is incorrect. Ethers are not the most reactive. Okay, these are the least reactive. So that is why they are least reactive. So we need more drastic condition. If something is more reactive, then it can easily form the product. If it is less reactive, then we need to provide more heat or something to react. Okay, so the correct answer is C. Ethers are least reactive, and that is why ether cleavage takes place in excess hydrogen halide. So this is the reaction for the same. Let's see the next question. It says 7.5 gram of ethoxyethane and 9 gram of butane one all is miscible to almost same extent, while pentane is essentially miscible with water. And the reason is alcohols and ethers can form hydrogen bonds with water molecules. See, the answer would be A. Both are correct, and reason explains why. Because you see ethoxyethane and butane one all. It has this group and this is OH. Both have oxygen, so they can form hydrogen bonding. Okay, with water. So this there would be stability with water, but pentane it does not have OH group, no OH group. So that is why we have option A as our answer. Now let's see the next question. Assertion says alcohols do not react with NaBr but H2SO4, but when H2SO4 is added, they form alkyl bromides. One reason is given that water is a good leaving group. See, again we have option A. Why? Because see, Br is a strong nucleophile, but OH is a strong base, not a good leaving group. It is poor leaving group because neutral species or electron or like which have neutral species or OH2 positive, you can say, they are good leaving groups, so they can leave easily. Okay. So Br cannot displace OH from OH to form Br. Hence, alcohols do not react with NaBr. However, when H2SO4 is added, protonation of alcohols take place and OH group gets converted to OH2 positive. Alright. So, water is a weak base. It is a good leaving group. Br can displace H2 from protonated alcohol to form RBr. See, we have now our OH2 positive from here and easily Br can displace. And we will have alkyl halide. Let's see the next question. Assertion says orthonitrophenol is less volatile than paranitrophenol. Reason says there is intramolecular hydrogen bonding in orthonitrophenol and intermolecular hydrogen bonding in paranitrophenol. See, the intramolecular hydrogen bonding looks like this. This has good hydrogen bonding with this. And intermolecular is between different molecules. The intramolecular is in the same molecule. So intermolecular is between two different. Intermolecular is stronger. If this is stronger, then upon boiling, Volatile, what is volatile? That upon boiling it can easily go or not, like it will evaporate or not. So if it has stronger bond, it will take time. It is lesser volatile. Which is less volatile? Para. And here it is given ortho, so assertion is false and reason is true. The correct answer is B. Let's see the next question. The large difference in the boiling points of alcohol and ether is due to the presence of. Now again you see. It is because of the hydrogen interaction in alcohol. OH. This has a stronger bond, okay? This is hydrogen bonding, which is stronger. In ether, there is no such bond. It is hydrogen bonding in alcohol. So I hope this is clear. For any doubts, you can just message us on the WhatsApp group that we have. So thank you. Have a nice day.